With the second page of the study guide, a couple of theorem questions. A little tricky here. Number 4 says f is defined, not continuous, f is defined on the closed interval from 0 to 1 and satisfies the following. F of 0 equals f of a half equals f of 1. On the open interval, so not including the endpoints from 0 to 1, f is continuous and strictly increasing. Which of the following statements is true? So what we're trying to do here is figure out what exactly is being described by this information. So perhaps if we take a little thought of it, we're looking at something like this. I'm going to make this really long on the, so here let's call this 1, so that way we can call that a half. All right, so what we know, we know that f of 0, f of a half, and f of 1 are all going to be the same value. So let's just do this. There we go. F of 0, f of a half, and f of 1 are all the same. Well, as close as I can make them. Now, on the open interval from 0 to 1, f is continuous. So notice it does not include the endpoints, which means that when we start graphing, and I'll change the pencil here, when we start graphing f, in between, it's not going to be continuous with this point, nor is it going to be continuous with that point. What will be is continuous in between and strictly increasing. So we might be looking at something like this. All right, so the graph f of 0, f of a half, and f of 1 are all the same. And between 0 and 1, the function is increasing. It's strictly increasing, all right, and is continuous. So something along those lines. Again, not drawing the best, but get the general idea. So what's true about this? Well, f attains both a min and a max? Nope, because we don't have a min, and we don't have a max. So we're actually looking for the one that says neither. And that's what we have down here. F attains neither a max nor min on that closed interval, because they're asking about the closed interval, and these endpoints screwing everything up. So the answer is D. All right. This is our extreme value theorem. In essence, is being checked there. So they're asking us. Remember, the extreme value theorem says continuity. We're only told continuity on the open interval, but they're asking us about the closed interval. So the extreme value theorem is not guaranteeing either a min or a max. All right. The graph of the differentiable function f is shown above on this interval. How many values of x in the open interval -4 to 3 satisfy the conclusion of the mean value theorem for f on -4, 3? So here's -4, and here's 3. So if we're talking about the mean value theorem, remember that means that the derivative at some value c, which is what we're interested in, some value, the derivative is equal to the average rate of change. So if we draw the average rate of change, let me turn my paper here so I can get a little better. Right, here's our, there we go, there's our average rate of change right there. So the slope of this line is the average rate of change. So if we want the derivative to be equal to this, that means we need some tangent lines, because the derivative is the slope of the tangent line, which are parallel to this red line. And I think we can get 3 of them. Again, I'm going to turn my paper just momentarily. I think we can get a tangent line here, and here, and here. So there are 3 spots. Let me turn this back and give everybody vertigo. There are 3 values of x in between at -4 and 3, in which the slope of the tangent line is equal to the slope of the secant line. So our answer will be 3.